Hi, I am Jintu from Team Discovery. This is a software design document presentation video of our project. Team Discovery is a group of final year computer science students from the University of Adelaide. We are currently working on a project called Hazard Removing Robot. These are the things that I will be covering today in this video. First, I will give you a brief introduction of the software design document. Then I will be explaining about the system architecture and components design, data design, design materials, human interface design, hardware design, and resource estimates. This software design document will give you a very comprehensive and detailed explanation of the software design of this project. At the end, we have also briefed the hardware design details, which will give you an idea of how we have designed the robot hardware. The primary audience of this document will be the software developers and the quality assurance team. Now, I will explain about the system architecture and components design. The canine robot system will be based on a MVC, that is a model view controller design. The MVC design requires the system components to be split into three categories, that is, model, view, and controller. This is an overview of how MVC works in our system. The user in the diagram refers to the operator. The controller has to interpret user actions such as button clicks. Controller will then send this interpreted data to the model for processing and manipulation of the data. The next component in the MVC design is the model, which is where the processing and manipulation of the data occurs. Once processing is done, the data will be sent to the view to update the GMCS. The last component is called view. The function of this component is to translate and display the data received from the model into GMCS. Next is the components design. We have mainly two system components in this project, the GMCS, which is the host, and the canine robot. The GMCS enables the operator to communicate and remotely control the canine robot. Since the host has more computational power, most of the processor-intensive tasks such as data processing, pathfinding, etc. are done in the host. These informations will then be sent to the robot side. The robot side will be collecting data from sensors such as ultrasonic sensor, color sensor, etc. and sending this data to GMCS for processing. It will also be listening to the commands from GMCS and operating according to it. Moving on to the data design. In our project, we are storing data such as robot position, hazard position, drop-off point, and no-go zones in XML format. These data will be stored in XML using the tags initial pose, hazard pose, drop-off location, and NGC respectively. Now we will discuss about the design details. The design details consist of class diagram and sequence diagrams. We have separate class diagrams for robot side and host software. This is the robot side class diagram. As you can see, this is not the full class diagram as I have omitted the attributes and behaviors of the classes to make it readable. This class diagram will give the developer a good idea of how to develop the software. This is a similar class diagram for the GMCS. Next is a sequence diagram. A sequence diagram is an interaction diagram that shows how objects operate with one another and in what order. The first sequence diagram is for GUI robot connection. This diagram has user, GUI, and robot. When the user enters the IP address and presses connect in the GUI will send connect request to the robot. Upon successful connection, robot will display connected. Then the user will be notified in the GUI about the connection status. Next sequence diagram is for loading the map and setting the locations of robot, hazard, drop-off point, and no-go zones. The user will first load the XML map and GUI will display the loaded map. Next, the user will set the positions of robot, hazard, drop-off point, and no-go zones. The user will be notified if the location set is valid, and these locations will be sent to the robot. Once all the locations are set, the GUI will calculate the optimal path and it will be sent to the robot. Next sequence diagram is for changing the control mode of the robot. When the user selects auto in the GUI, the navigation buttons will be disabled and the robot will change to auto mode. The user will also be notified with a message in the GUI. If the user selects manual in the GUI, the navigation buttons will be enabled and the robot will change to manual mode. Now we will discuss about the human interface design. I will be briefing about the main components in the GUI. This is how the whole user interface looks like. It has the following components. A menu bar. The file menu lets the user load the XML map and also exit the GUI. Edit menu will enable the user to edit the already set locations. Help menu will let the user to refer to the user manual. A map panel. The map panel is divided into grid squares. Operator can set the locations of robot, hazard, drop-off point, and no-go zones by dragging and dropping the icons in the map. A connection panel. This panel lets user to enter the IP address of the robot and connect to it. It also has buttons to choose between the auto and manual modes. Robot details panel. This panel displays basic details such as speed of the robot, battery status, current control mode, current location, total distance traveled, and total time taken. Event log panel. This panel will display the major events that occurred during the operation. Examples are map loaded, location set, control mode change, etc. Robot control panel. Robot control panel has navigation buttons to manually navigate the robot in the map, grab and drop buttons to grab and drop the hazard, and an emergency button to stop the robot in the auto mode. Next is the hardware design. This is the front and side view of our robot hardware design. This is designed using Lego Digital Designer, which is a free computer program produced by the Lego Group. We will now move on to the resource estimates. The hardware requirements for the host system are a computer with a Windows 7 or above, or a Mac OS 10 or above, a 32-bit or 64-bit processor with at least 2 GHz speed, a 2 GB RAM, 1 GB storage space, and a USB Wi-Fi adapter. We are using a Lego Mindstorm EV3 robot kit for this project. Software requirements for this project are Java JDK 7 or above, Lego EV3 0.9.1, Apache and version 1.9.6 for building Java application, Eclipse Neon 4.6.0 or above for software development, Lego's plugin for Eclipse for robot side program development. Thank you for watching.